Hi everyone. I guess it's the first more practical presentation, so hope you enjoy it. I want to present one of my spare time projects, which I have joined last year. It's a Zephyr-based smartwatch. You can check everything out on my GitHub if you want to get any further informations. If I have some time at the end, I can show you a demo or something else, but let's stick to the slides first. So what is the agenda? A few words about me, then we dive into the idea behind the project. I will show you the hardware and the software, what's up in the future for the project, maybe the short demo, and some Q&A. So about me, my name is Daniel. I'm 34 years old. I'm from Hagenbüchach, that's near Nuremberg. So I'm a passionate electronics engineer. I say my work becomes my hobby and my hobby becomes my work. So it's not sure if I'm working or I'm doing some stuff for me. So I do a lot of electronic coding and whatever stuff. I'm currently working at RTOS and Zurich, a huge automotive supplier in Nuremberg. I joined the watch project last year in August before my wife got our child, and I need to spend some time with before I get a father, and I don't have any more time for projects. And it's and it's basically my first Zephyr project, so I'm quite new, but it's quite interesting, and I did a quick start into the project because there was a lot of firmware already there, so I was able to use it. So what's the idea behind the project? There are a lot of smartwatches available in the market, but all smartwatches are not so nice to repair, and you don't belong to the hardware and the software. So Jacob had the idea to build an open source smartwatch where everything is open source, beginning with the programmer you can see here, and the electronics PCB and the firmware running on both, but not the programmer. It's closed source, but you can leave it out and use some other programmer and use this PCB basically as an adapter for the watch. So if you want to have everything under your control. And the watch should look nice. So that's basically the last version we had and the one I'm wearing already. Yeah, how does the hardware look like? It's quite packed. It's very challenging to get everything into a small device. So we have this main PCB with a lot of stuff on it, some 3D printed components to fit everything together, a vibration motor, a battery, a display, and housing. The housing can be milled or 3D printed or injection molded and so on. We got a nice transparent housing from China for, I think, 40 euros or something like that. It's really cool looking. So it's a very cool device in transparent, basically. So let's take a look at the main board. As you can see, we have a lot of nice stuff here. The new Nordic NPM 1300 PMIC, which we have added last year. Then an RTC for stopwatch, alarm, and basically the time. An NF53 system on module. A lot of flash memory because we need a lot of flash for the UI. A microphone for some audio recordings and maybe machine learning later with TensorFlow. a magnetometer for a compass, basically, a light sensor, an environment sensor for indoor air quality measurement, a buzzer to play fancy sounds, a pressure sensor, basically to have a more accurate pressure sensor than from the BME, an IMU to do some gesture recognition, haptic driver for the motor, display, and battery connector. And here you have the dock connector for programming, charging, and in the latest version for USB. So we switch between USB and debug interface by using this nice switch. So we have basically both on 2 pins. Here you can see the programming device, or the dock, so to say. It's basically a complete J-Link debugger where we got some licenses from Zephyr for free. So a great thanks for this. Otherwise, we have to pay for each PCB, and that's not cheap. We have a data and debug interface. The data interface is directly connected to the watch, so we can connect the watch directly via USB to a PC. We have some current measurement on it and some switches to select different modes. The board is available in 3 variants, so if you don't want to use the Sega debugger on the board, you can leave out the STM and connect something else you have already on your desk to this board and debug with your own debugger. So it's basically an adapter board. Yeah, the software, it's growing over the time, and it's by far not perfect so far. So it's based on the NCS, I guess version 2.7, so the latest version from Nordic with Zephyr inside. We added some external drivers for the sensors. So for example, we had to adjust the BME driver a bit to get this indoor air quality measurement added to it, and the gesture recognition has to be added too, because the Zephyr drivers are quite basic. The RTC driver is completely new, and it's basically pushed in the latest version of Zephyr. So I added it to the main branch lately. So then we have a couple of sensor glue code, basically to connect the sensor drivers with the applications. The managers for app notifications, phone connection, and power, also basically BLE. Then display and buzzer and haptic drivers for the human-machine interface, and event handling like flickering with the arm, so the watch wakes up and enables the display, standby modes, and so on. Yeah, we have a couple of additional features in the software. So this is the 5th hardware version of the watch, and we use basically one software version. Everything is done via device tree overlay. So we have one overlay for one PCB version. So we we don't have that much complexity in different board versions. We just exchange the device tree and everything is running fine. The software is built in CI/CD. The hardware also, so it's quite nice. We don't have to do that much when we change something. Everything is available on GitHub. So if you push a new hardware version or a new PCB, basically, you get all the nice manufacturing data out of CI/CD, so no more handwork. That's really, really nice. We have a POSIX build to develop UIs on the PC, so you don't need a hardware. So if you want to develop an app, you can just use the POSIX build in Linux and build your app and then say, hey, I have an app, please test it on a watch. For testing in the real world, we have added core dump because we figured out that it's quite nasty to track issues when we don't know why the issues happened, and sometimes the watch crashed, and we don't know why. So it's quite nice when we have this in debug builds. And there's a guy on GitHub called Felix Biego. He has created some watch faces for ESP-based smartwatches, and we were able to use these watch faces for our smartwatch. So we have a large selection of watch faces available, and you can switch them during the runtime. So you can customize the watch if you want. Yeah. Then obviously we need apps for the watch to give it some sort of functionality. So we built a very basic app interface currently. So an app is defined in a structure with an app start and stop function. These functions are called when you close or open the app. And in the app start, you basically build up the UI. The UI is built with LVGL. And there you can build something like this for the battery, for example. And then you can add some additional logic, and your app is done. You compile it, and you have the app basically added to the watch. Yeah. We have a lot of ideas for the future, but not enough time. So one of the ideas is running classic Doom. I guess 2 weeks ago, we figured out that someone has ported Doom to an NF53 platform. So we tried to adapt it. Jacob is doing the software stuff basically, but he has to switch the house currently, so he has not that much time, but this is one of his favorite projects. One of my favorite projects is to bring back a heart rate sensor. We had one heart rate sensor in revision 2, but it doesn't work quite well. And we had the issue that the sensor hasn't touched the skin because the height was too high. So we have to adapt it, and the idea is to use some sort of additional PCB and connect it to the main board. LE audio with AI integration, as mentioned before. It's in progress, but to be honest, I don't know how good it's work currently. A big topic is a companion app for the smartwatch, for the smartphone to connect the watch with, because currently we are using Gadget Bridge, which is nice, but not very good. For iOS, we don't have a companion app because Gadget Bridge is Android only. A new housing, which is done by someone who has more experience than Jacob and me in doing housings, because the current housing is not that nice to assemble. Big topic will be the switch to NRF54, because we need more speed on the SPI for the display, because the display is quite laggy sometimes, and more flash memory, obviously. Finding someone who helps us to sell the watch. So we don't have experience in selling a product, all the certification stuff and so on. So if someone is interested, feel free to contact us. We have a lot of people who are interested in this watch, so it's not very unlikely. Yeah, and then clean up code, update documentation, build up more templates for software developer, and so on. it's basically work that has to be done, but we want to build the watch and not writing documentation. So if you want to write documentation, feel free to contact us as well. Okay, not sure if I guess I have a bit of time, so let's quick dive into a demo. Hopefully it works with a touchpad on my laptop, because I tested it with a mouse normally. So I mentioned we have a POSIX build. So we can do it here in Linux. So here is it. You have basically the watch interface. You can navigate through the UI. Here you see we have some applications running on it. Basically the game 2048. I guess everyone knows it. The battery app I showed before, obviously it's not working in the POSIX build because we don't have a PMIC. What's working here? The watch face picker is working. It's not the latest version, so please forget this black screen. There should be an image. Does it work? Yeah, and now I can here select a new watch face, close it, and I have a new watch face. Yeah, and if you build a new app, the app will appear here, and you can use it here for music with Android phone, for example, or the core dump feature, for example. So if a watch crashes, you have a core dump here, you can select it, and then you download it via USB or SWD, and watch it on your PC to figure out what's going on. So it's quite nice when you use the watch during the normal day. Yeah, and I guess I'm done. So it was a bit fast, sorry, but the presentation was initially done for 30 minutes, so I have to strip it down a bit. But you can you can support us. We have a Discord. Just scan the QR code. It's not malicious, so don't don't be scared. And GitHub. Or we can stay in touch. So here you can get my business card if you want to get more information about the project, or want to join the project, or you have some new ideas, or you want a watch, etc. I also have some hardware here. If you want to see the debugger or the watch, reach out to me and I can show you everything. Also the watch, it's not a secret. So feel free to contact me.